To enhance the use of insecticides and acaricides, it's essential to understand their modes of action, how they penetrate the bodies of pests and mites, their performance, action features, and application methods. Applying the best insecticides and acaricides and combining them with other pest control methods can help boost crop yield. 1. Insecticides and acaricides mode of action. Conventional insecticides and acaricides work through contact action, stomach action, systemic action, and fumigation action. Target-specific insecticides work through attractant action, repellent action, antifeedant action, sterilization action, growth and development regulation action, etc. 1. Contact action. Contact action occurs when an insecticide enters pests' bodies through contact with their epidermis, leading to poisoning and death. Insecticides with this effect are called contact insecticides. It is the most common mode in modern insecticides, and most insecticides, including pyrethroids and organophosphates, work well in this regard. 2. Stomach action. Stomach action occurs when an insecticide is ingested by pests through their mouthparts and acts within their digestive systems, causing poisoning and death. Insecticides with this effect are called stomach insecticides, which are effective only against pests with chewing mouthparts such as Lepidopteran larvae, Coleopteran, and Hymenopteran pests. 3. Systemic action. Systemic action occurs when an insecticide is absorbed by a plant and transported throughout its tissues to exert its effect in other parts of the plant. Insecticides with this effect are called systemic insecticides, such as imidacloprid and thiametoxam. These insecticides are mainly used to control pests with piercing, sucking mouthparts, such as aphids, mites, scale insects, and fleas. 4. Fumigation action. Fumigation action occurs when an insecticide enters pests through their respiratory systems as a gas, leading to death. Insecticides with this effect are called fumigants. Since fumigants enter pests in a gaseous form, they must meet two application requirements. First, fumigants must be applied in a closed space to prevent leakage. Second, higher temperature and humidity are needed to help fumigants diffuse better in a closed space. The application of fumigants can easily cause poisoning accidents, so it must be carried out by trained technicians. Many insecticides and acaricides, like thiamethoxam, typically work through multiple modes of action. Generally speaking, stomach insecticides are the first choice for pests with hard chewing mouthparts. For pests with fragile chewing mouthparts, both stomach and contact insecticides can be used. For pests with boring, chewing mouthparts, systemic insecticides should be the primary choice. For pests with piercing, sucking mouthparts, systemic insecticides are preferred, but contact ones can work too. However, for scale insects and psyllids with a thick, waxy integument, contact insecticides are not recommended. For highly mobile pests with piercing, sucking mouthparts, such as leafhoppers and greenhouse whiteflies, fumigants should be the primary choice. For underground pests of any type of mouthpart, contact soil treatments should be the primary choice, with fumigation used in fields with plastic mulching and drip irrigation. 2. Pathways of entry into insects' bodies. After application, insecticides and acaricides must enter the bodies of insects or mites and reach the target sites to exert their toxicity. Insecticides and acaricides usually enter insects via their mouthparts, integument, or spiracles, via the mouthpart. Insecticide can only enter an insect's body through its mouthpart if the insect fits. This means insects shouldn't avoid or develop deterrence to the insecticide-laden food. If the insecticide concentration is too high, the insects may avoid feeding, thereby reducing its efficacy. Vomiting during feeding by pests with chewing mouthparts can prevent insecticide from entering via the mouthparts. This issue is seen with inorganic insecticides, but is more noticeable with synthetic organic ones via the integument. The integument is the primary barrier preventing contact insecticides from entering insects. Any insecticide must first wet spread and adhere to the integument to dissolve the cuticular wax, allowing the insecticides to penetrate the epidermis. Thus, an effective contact insecticide should be highly lipid-soluble and moderately water-soluble. Emulsifiable concentrates of pesticides have excellent wetting properties, allowing them to wet spread easily across insects' integument. The solvent dissolves the cuticular wax, enabling the insecticides to penetrate the epidermis, resulting in a potent contact toxicity. Insecticides with high water solubility are less effective in contact action. 3. Via the spiracles. Most terrestrial insects have a respiratory system composed of spiracles and a tracheal system. Gas insecticides can enter insects through their spiracles as they breathe, then travel through the tracheal system to the microtracheae to exert toxicity. Spray-type contact insecticides rely on their wet-spreading abilities to enter the spiracles, similar to how they penetrate the cuticle. Thanks to their superior penetration ability, mineral oil emulsions pass through the spiracles more easily than regular emulsions. After reaching the tracheal system, they cause blockages, preventing gas exchange and suffocating pests. That's it for today. You can refer to more sources to get a deeper understanding of how insecticides and acaricides work. Thank you.